Greetings, A-level chemists. Okay, here we've got an iodine clock reaction question, and it's from an Edexcel IAL paper, and only 1 mark for A and B, but quite a good question actually. So what happens if the amount of HSO3 minus ions were in excess? Okay, before we actually answer the question, let's do something which often gets left out of this section, about why the blue-black color with starch actually appears in the first place, okay? Now, in biology, I think they tend to just say if iodine's present, starch goes blue-black, and that's not true, okay? So starch will only go blue-black if you have I2 present, molecular I2, and the iodide ion, and what you form is something called the I3 minus ion, which is triiodide, which is a linear molecule which looks like this, okay? Now, you need both I2 and I minus. Once you form the I3 minus complex in the presence of starch, then it will go blue-black, and it's a very sensitive reaction as well, okay? So that's really important to actually understanding what's going on. So, let's have a look at reaction 1. We've got shed loads of HSO3 minus ions if they're in excess, and it's forming I minus. Cool. The I minus goes on to be oxidized to I2, but look, if that was in excess, you've still got some HSO3 minus ions here as well. And what's going to happen is all the I2 is going to react, and it's going to be reduced back to I minus. So you're never going to get that blue-black color because you don't have any I2 ever forming. So let's actually answer this. So no iodine, I2 will form. And you can say as reduced to I minus in reaction 3. And the consequence of that is no color change, or no blue-black color will be observed. Okay, 1 mark. Nice question. Okay. Question number B. Why is it important that reaction 2 and 3 are much faster than reaction 1? Okay, another little lovely 1 marker that most people probably drop a mark on, but let's try and get that mark. So, the fact that if reaction 2 and 3 are way quicker than reaction 1 means that actually we can study the kinetics of reaction 1, okay? Because the I minus is going to be rapidly converted to I2, and the I2 is going to be rapidly converted into I minus. Now, if reaction 2 and 3 were a lot slower, the consequence of that is going to be that the blue-black color is going to appear way too soon, way too quickly for us. And that's a response. The blue-black color would appear too quickly otherwise if they were really slow. Okay, because what would happen is you'd have some I2 and I minus, and if you have I2 and I minus, you'll get that I3 minus forming, and that blue-black color would appear too quickly. So we need reaction 2 and 3 to be fast to study the kinetics of reaction 1. Question number C, why is it important that the temperature is kept constant? Well, you could argue that in the rate equation, I don't know what the RDS is, I think it's actually reaction 1. I don't know what the molecularity is, but let's just say that for a general reaction, you can say that the rate is equal to K, the concentration of species A raised to some power N, concentration of species B raised to some power N. Okay, where M and N are the orders determined from experiment. Now you could say, well, actually, does temperature affect the rate? Because I don't see a temperature variable in the rate equation. Well, where is it? It's hiding in K, okay? So K is the rate constant, and the rate constant is equal to A base E minus EA over RT. So this is the Arrhenius equation, and you can see that the temperature variable is within K. So we just teased it out, okay? So actually answering the question for 1 mark, why is it important to keep the temperature constant? Well, temperature affects the rate because it affects K, and K is in the rate equation. And the short answer is temperature affects rate. Ta-ta. If you're enjoying this content, please subscribe to my channel and click the link in my description to sign up to my course.